Okay, so on the chart it was A. This is our initial pH. So this is going to be controlled. We'll have our A2 minus plus hydroxide. Sorry, that's the reaction happening with titration, but here no titrant has been added yet. We're just going to have this equilibrium happening. Let me keep my ordering consistent here. I'm calling this HA minus plus OH minus, right? So this is our base hydrolysis reaction. So our initial concentration of our weak base here was 0.1 molar. We're going to have X of that will react, react with the H2O and will form HA minus and OH minus. And so we can solve this by, not Ka, KB1 is equal to X squared over 0.1 minus X. PKB1 was 10, I believe. 4. PKB1 was 4. Yeah. So we'll get 10 to the minus 4.00 is equal to X squared over 0.1 minus X. And X, which is the hydroxide ion concentration, is equal to 3.11 times 10 to the minus 3. And skipping a couple steps, that gives us a pH of 11.49. Okay, so nothing too exciting there. All right, so next we'll have the buffer region. So this is point B on the chart. And specifically look at the halfway point to make the calculation easy. We know that at the halfway point, our concentration of A2 minus is equal to the concentration of HA minus, which means this is a case where we have pH is equal to pKa. Now the key here is to figure out which pKa is equal to. So it's going to be whatever is our acid that goes into, so it'll be the pKa for HA minus, and this will be pKa2. So that was a value of 10. So that's our pH halfway through. Now we could find the pH at different points along the curve, but at halfway, that's the easy point. We'll just stick with that. But you would do it the same way for any other point along the curve where you'd use the Henderson-Hasselbalch equation. Okay, at point C, this is the first equivalence point. We have only HA minus. So this is the point at which all of our A2 minus has reacted and become HA minus. This is our intermediate form of our diprotic species. So we can use the fancy long equation, right, that we derived. Concentration of H plus is equal to the square root of K1 K2 F plus K1 KW divided by K1 plus F, if you remember that. Or we can use the simplified form where the pH is approximately equal to 1/2 of pKa1 plus pKa2. And so we'll use the second form, which gives us 1/2 times, let me get my numbers here again. pKa1 is 5. pKa2 is 10. 1/2 of 15 is 7.50. And this will get us pretty close to what we would get from the longer equation, as we have seen in the past. Okay, so that is the first equivalence point. So just to keep this video from getting too long, we'll look at the second buffer region and the second equivalence point in the next video.